Use the identity that sine theta plus phi is equal to sine theta cos theta sine phi to find identities for cos theta plus phi, sine theta minus phi, cos theta minus phi, tan theta plus phi, tan theta minus phi. Now I apologise, this video is quite long, but please bear with me and try to follow it through to the end. Now, in the previous video, we derived sine theta plus phi, sine theta cos phi theta sine phi. I'll put the link to that video in the notes of this video so you can go back and refer to it. So if we're going to use the idea that sine of 90 degrees minus theta, let's have a look to see what that actually means using this GeoGebra applet. Now the GeoGebra applet, again, I will put in the notes of the video. So we've got the green graph here, which is sine theta from minus 360 to 360, and the blue one is cos theta. And if we click here, okay, at the moment theta is on 30 degrees. Now if I work out sine of 30 following the graph up, I get this value here. It's actually 0.5. If I did cos of 90 minus 30, so 90 minus theta, I also get 0.5. So that's actually true, that sine theta is the same as cos 90 minus theta. Let's just take another value of theta to see that as well. Let's take a lower one. Let's take 11. So sine of 11 is about this value, about 0.2. Okay, and then 90 minus theta will be 79. So cos of 79 is the same value, and that's true wherever you put theta. Okay, it's true wherever you put theta. It's always going to be true. Okay, so we end up with a couple of identities that sine theta is equal to cos 90 minus theta, and cos theta is equal to sine 90 minus theta. Those are worth remembering. So using those identities, so I'm now going to do sine of 90 minus theta plus phi, all in brackets, and what I've got to realise is that's going to be cos of theta plus phi, treating theta plus phi as theta in this. You can see that it's going to be the same thing. Right, so now everywhere I'm going to just expand that a little bit. So it's going to be sine of 90 minus theta minus phi, and sine of 90 minus theta plus minus phi, which is the same thing as that. It's going to be sine theta, which is now 90 minus theta, cos of minus phi, plus cos of 90 minus theta, sine of minus phi. So what I've done, I've made theta 90 minus theta and phi minus phi, just substituting into that. So that's going to be, this gives me cos theta plus phi, so that's going to, sine of 90 minus theta is cos theta. I'm just going to leave that as cos minus phi for a moment, and cos 90 minus theta is going to give me sine theta. And then sine minus phi is going to give me sine minus phi. Now, are there relationships for cos minus phi and sine minus phi? So let's go back to the GeoGebra applet. Again, I'll remind you that it's in the notes of the video if you want to get it for yourself. And deselect this, and just select for minus phi. So at the moment we've got sine of 30 is 0.5, but sine of minus 30 is minus 0.5. If I move this, okay, if I move this, if I move this, let's do 60, you get this value here. This length here, if I do sine of minus the same value, I get the same length but negative. Therefore, sine of minus theta is minus sine theta. And that's worth remembering. If I do for cos, let's take 50 degrees, for example. So cos of 50 degrees gives me this value, and cos of minus 50 gives me this value. So it doesn't matter where I move this along, that is always true. Cos of minus the angle is always going to be the same as cos the angle. That's because cos is an even function, and sine is an odd function. Again, everywhere it's always going to be, it doesn't matter where I move it, it's always going to be they're always going to be in the opposite direction, because cos sine is an odd function. Okay, so we've come up with the thing. So sine minus theta is equal to minus sine theta, and cos minus theta is equal to cos theta. And this idea is going to be used a lot in this video. Okay, so now cos minus theta is equal to cos theta, and sine minus theta is minus sine theta. So this now becomes cos theta plus phi is cos theta cos phi. This now becomes cos phi plus sine theta sine minus sine phi. So that becomes cos theta cos phi, minus times a plus gives me a minus, so I get sine theta sine phi. Now if I do the next one, which is sine theta plus phi, which is, again I start with sine theta cos theta phi, cos theta sine phi, and I want to do sine minus phi. Instead of phi in here, I now put in minus phi, so it becomes sine theta minus cos minus phi, cos theta sine minus phi, and then like I've just told you, cos minus phi is cos phi, and cos sine minus phi is minus sine phi. So we're going to get sine theta minus phi is equal to sine theta cos phi minus, because this becomes minus sine, so minus and a plus becomes minus, cos theta sine phi. Similarly, we can do cos of theta minus phi by looking at cos theta plus phi and putting in minus phi for phi. So we get cos theta minus phi, that gives me cos theta cos minus phi minus sine theta sine minus phi. That gives me cos minus phi is equal to cos phi, and sine minus phi is equal to minus sine phi. So it gives me cos theta minus phi is equal to cos theta cos phi. Cos minus phi becomes just cos phi, plus, because sine minus phi becomes minus makes a plus, sine theta sine phi. So there we have the relationship for sine plus or minus phi and cos plus or minus phi. Now for tan, we have to use the idea that tan theta is equivalent to sine theta over cos theta. So tan theta plus phi will be sine theta plus phi over cos theta plus phi. Using the expansion for sine theta plus phi, we get sine theta cos theta sine phi, and then cos theta plus phi, we're going to get cos theta cos phi minus sine phi theta sine phi. And now we do a little trick. Now the trick is to look what we've got here, cos theta cos phi, and divide everything through by cos theta cos phi. So if we do, so get sine theta cos theta divided by cos theta cos phi, cos theta sine phi divided by cos theta cos phi, cos theta cos phi over cos theta cos phi, sine theta sine phi over cos theta cos phi. Now here, these two will cancel out, these two will cancel out, all this will cancel out and become 1. So I end up with sine theta over cos theta, which is tan theta, plus tan phi over 1 minus tan theta tan phi, tan theta tan phi. And then to do tan theta minus phi, similar idea. You rewrite this as sine theta minus phi cos theta minus phi. Write down the respective expansions of both. Again, you're going to divide through by cos theta cos phi. So it's going to be very similar to the previous one, but the signs are going to be the other way around. Okay, and then doing the same cancelling as before. Okay, so we get tan theta minus tan phi over 1 plus tan theta tan phi. So writing them all out, so there's now 6. You get sine theta plus phi is sine theta cos phi plus cos theta sine phi. Sine theta minus phi is sine theta cos phi minus cos theta sine phi. Cos theta plus phi is cos theta cos phi minus sine phi sine theta sine phi. and then sine cos theta minus phi is cos theta cos phi plus sine theta sine phi. Notice the signs here are the opposite to what you think they might be. And then tan theta plus phi is tan theta plus tan phi over 1 tan phi theta tan phi. And then tan theta minus phi is tan theta minus tan phi over 1 tan theta plus tan phi. Also need to remember that in these cases that theta plus phi and theta minus phi cannot be equal to 90 to 70, because that's where the asymptotes appear on the tangent graph. Okay, so this has been a video to show you how to get to the proofs really of the compound angle formulae. I hope you've understood. The GeoGebra app is in the notes of the video, and the link to the previous video which drives the first one is also in the notes of this video. I thank you very much for watching.